So today I want to talk very specifically about quantum computing and AI. When it comes to speculating and getting my opinion regarding speculation and what I think will happen and all of that, the most common area or question that people ask me to speculate on is very specifically with regards towards this concept of quantum mechanics, quantum physics, quantum computing, and AI. So, very specifically, do I think that quantum computing is going to revolutionize AI and everything as we know it? The answer to that, I'll give you the upfront answer to that question, is that I think that there's an 80% chance that that happens within the next 5 years. And then if that doesn't happen within the next 5 years, it's not going to happen for 20 plus years. So that's kind of the breakdown, right? Like 80% chance that the world is completely changed within the next 5 years as we know it. We solve quantum mechanics and we move along. So 20% chance that everyone is completely wrong, we're all on the wrong track, and that nothing happens. And then if we're all completely wrong, then it's 20 years until that reset button hits again, until we get another stab at this, is kind of how I look at these things. Where we're at right now is that we are a place of understanding of physics where we now understand that our current understanding of physics is wrong. It's not only wrong, it's very wrong, disturbingly wrong. And so within that, that to me is the larger question that boils down within this. I understand like the crypto bros and now the quantum bros and all of that, right? Like they're very interested in the speculation of this for economic purposes. To me, I look at it beyond economic purposes, right? I think that all of this is beyond economics. It's greater than economics. It shapes economics as a whole if it's true. If we solve quantum mechanics, I think it invalidates economics as we know it today. Like it doesn't make any sense to focus on economics today if that's the outcome. It's kind of how I look at these things. So I don't necessarily focus on the economics of these questions. I focus on the science of these questions. And then so within the science of this question, very specifically of quantum mechanics and quantum computing and AI, the bottom line overall is that going back again, our understanding and our current understanding of these concepts is very wrong. Not a single person on this planet can tell you very specifically how these things operate, what exactly is going on, what is correct and what is incorrect. No one knows. No physicist on the planet knows because our entire understanding of these things keeps getting thrown into question. And this is kind of the bottom line here. I'll start here, right? And so we've been looking at this headline from the beginning of this video. Hubble tension controversy now turns into a crisis as new discovery challenges current models. And so if you've been keeping track of this, it's pretty straightforward, right? So Hubble tension, like the concept of Hubble tension, the Hubble telescope, etc., is there's a man at Hubble, right? And he's essentially created the modern understanding of physics as we know it with regards towards the universe, universal expansion, Big Bang theory, etc. Right? And then this all boils down to this concept of Hubble tension, which is everything fits within a box except for this Hubble tension, right? And then so for the last 40 years, we've been operating under this concept that everything operates under a Big Bang theory and everything ties back to that. And then we can get our models to model the universe 99% accurately according to these models. But the more and more accurately that we can measure the expansion of the universe, there's a problem, this Hubble tension. And it becomes a bigger and bigger problem the more accurately that we can measure it. And then so now the tension now turns into a crisis because we essentially have been able to measure accurately enough within this that we can now state definitively that our understanding of Big Bang theory and how the universe expands and operates within that has been taught is wrong. I can't tell you what is correct within that, but I can tell you that current understanding is scientifically wrong because the Hubble tension is wrong. The way that we got at and arrived at that conclusion is incorrect data, basically. So the universe is expanding, which is proven by Hubble and all of our experiments within that. But the experiment is expanding at faster rates than can be mathematically predicted under any current model of physics. And that's kind of the bottom line here, right? And what all of this breaks down, and this article, and there's a bunch of articles that have come out within the last few days here, right? Physics.org. This is big, right? It's not just me pulling one article in this instance. Like this instance of Hubble tension and what's going on here is becoming more and more of a crisis, of an overall crisis, because it proves more and more definitively that our understanding of physics as a whole is broken. It's not fully there, right? And we bump into this with AI more and more, and within AI spaces more and more, right? Within HDC computing, LCM models, how like exact linear geometry, programmatic programming, all of this, right? Like all these kind of new theories that are coming out and that are working because they come out because they're working are uh, all operating off of incorrect physics, right? If we go off of our current understanding of physics. Essentially, what I'm saying within this is that for the last year, 2 years plus, if you've been at the forefront of AI and computer science and trying to advance and understand these things anyway, you've reached this conclusion 2 years ago that there is something fundamentally broken with current physics. And so we've moved beyond current physics. Like in my research, especially within like HDC spaces, things like that, I make flat out assumptions at this point regarding physics. I'll tell you my flat out assumptions. I make very simple assumptions and very simple twists to our current understanding of physics. I take the Einstein equation and I make one simple change to it. I change the gravity. I change the gravity constant to a variable that I call TG, which stands for time gravity, which is a multidimensional variable. And that's the only change that I make to the Einstein equation. And then I also extend that out to the Schrodinger equation, etc. And then I do a lot of the math for my experiments based off of that change. Breaking it down into simplistic terms, how I do my math a lot of times and how I model my digital universes is that time, gravity, dimensionality, etc., all are a part of and come out of light. That basically light is we know according to current physics that light is both a particle and a wave. Why is that? Because it's the both are in light. That's kind of my hypothesis within that, right? So I do the math. I just simply make a few simple tweaks to our current mathematical formulas to plug in these equations. And when I do this, it works for me. And then so that's why I think we're 80% of the way there. Can I solve quantum mechanics for you right now? No, if I could, I would do it for you and I would demonstrate it for you that I've fully solved through those things. Like mathematically, my model works more and more than this Hubble tension model. And we can see more and more that the current models are breaking down, right? And there's more and more people coming to the same conclusion and understanding this. Step one, though, is where we're at right now, understanding and proving that our current understanding of physics is broken. In order to prove what is right with physics and what is wrong, we first have to come and to this simple understanding that our understanding is broken. Are we going to solve it from here? Is quantum computing going to be the answer from here? I don't know, right? Because our current understanding of physics is broken. What I tell you today with regards towards the mechanics of quantum mechanics often changes tomorrow, right? If I were to tell you and make this video a week ago, I would say that cold fusion isn't possible. But I've seen a research study plausibly that has come out that refutes that. Right? And there's lots of studies that have come out previously that refute that. But there's more and more studies coming out recently that are changing our fundamental understanding of quantum mechanics like this. And so it's really, for me, impossible to say whether or not quantum computing is going to revolutionize everything. I'll say something here that will probably blow a lot of people away. I'm not fully convinced that quantum hardware is necessary for any of this. If you look at a recent example of, I made a video on it, where they researchers took a normal llama model, just a llama 3 model, a standard llama model, and trained it on Grover's search algorithm, so quantum search, and just trained it how here's tokens to do quantum search, and then simply by training it on the data set, the model was all of a sudden able to utilize quantum search within its predictions, right? And then so there's a whole layer of quantum mechanics that we don't understand any of the mechanics of it. How exactly does that work? Like, I can just simply teach a model, here's what quantum mechanics is, and then all of a sudden it can do quantum mechanics. That kind of flies in the face of a lot of this, right? And then just goes back to, again, our current understanding of physics just overall is broken. How do you explain that? I can't explain it. You can't explain it. No one can explain why that works. Why I can just simply train an LLM model on quantum mechanics, and then all of a sudden it can employ quantum mechanics. Not predict it. It can employ it. It can employ it via predictions, which is kind of weird, but that's what's going on, right? So explain to me how exactly that's going on. No one on the planet can at the moment. No one can explain to me exactly how Hubble tension works. There's a lot. Just so overall, if you hear anyone make really definitive, sweeping claims with regards towards physics at the moment, like physics is solved, or physics is X, or physics is Y overall, or even if it's the Big Bang Theory is 100% true, I would dismiss that person on face. Flat out is where we're at right now with our current understanding of physics. And then so is quantum mechanics going to be and the future of AI, and is that quantum computing going to be the future? I don't know. 80% chance, yes, and then 80% chance that your entire life is going to change as a matter of fact with regards towards that. So 80% chance that all of this is irrelevant anyway. 20% chance that that doesn't happen, and then it won't happen for 20 years. I don't know. Take your flip as to which side you want to be on within that equation. But if you like this type of content, please like and subscribe. Thank you very much.